The first thing your senses lose isn't sharpness, it's the awareness that anything is missing. Your vision dims and you turn up the lights without thinking. Your hearing narrows and you start asking people to repeat themselves. And they do. Your sense of smell fades and food just becomes less interesting. 5 senses, 5 separate biological systems, all declining at slightly different rates after 40. And the most reliable signal that it's happening is that you've already stopped noticing. Here's what's actually happening. Your eyes, your ears, your nose, your tongue, your skin. 5 biological systems built around specialized cells that detect signals from the outside world and translate them into electrical impulses your brain can read. All 5 systems share a common vulnerability. The cells that do the detection don't fully regenerate. Once you lose them, they're gone. Or for the few systems that do regenerate, the rate slows down. Your brain compensates. It fills in what's missing, predicts what should be there, lowers the threshold for what counts as a signal. It's why decline feels gradual. Your brain is hiding it from you in real time. 5 senses, 5 mechanisms. Here's what each one is actually doing. Vision goes first, and it goes in 2 ways. The first is the lens inside your eye. Starting in your early 40s, the proteins in your lens accumulate damage and cross-link to each other. The lens loses flexibility. Your ciliary muscles still work. They still pull on the lens, trying to shift focus from far to near. But the lens is too rigid to respond. That's presbyopia. It's not a screen problem, it's a material science problem. Your eye lens is literally hardening. The second is happening at the back of your eye. The retina contains photoreceptor cells called rods and cones. Cones handle bright light and color. Rods handle dim light and night vision. Rods regenerate a chemical called rhodopsin, and after middle age, that regeneration slows down measurably. By 60, your dark adaptation takes more than twice as long as it did at 25. That's why night driving feels different. Why dim restaurants are harder to read in. Why the shadows in your peripheral vision feel less sharp than you remember. Your eyes aren't just getting older. 2 separate systems, one structural, one chemical, are declining at the same time. Hearing decline is mechanical. Inside your inner ear is the cochlea, a snail-shaped organ lined with 2 types of microscopic hair cells. About 3,500 inner hair cells, the primary signal carriers, and about 12,000 outer hair cells which amplify the signal before it reaches the inner ones. All of these cells detect specific frequencies based on where they sit. High frequencies near the entrance of the cochlea, low frequencies deeper in. These hair cells are exposed to every sound you've ever heard. They don't regenerate, and the cells that detect high frequencies are typically the first to thin out. Here's what's strange. You don't experience this as quietness. You experience it as confusion. Voiceless consonants, sounds like S, F, T, and TH, are made up of high-frequency components. When those frequencies stop reaching your brain, words don't get quieter. They get blurry. Sing and thing sound the same. 15 and 50 sound the same. That's why the TV is fine, but the restaurant is impossible. The TV plays speech at predictable volumes. The restaurant has competing voices, plates, music, all in overlapping frequencies. Your brain can't separate signal from noise the way it used to. The hair cells that used to do that work are gone. Smell is the most underappreciated sense. And the first one most people don't realize is changing. The olfactory system works through neurons in the roof of your nasal cavity. Around 10 million neurons in each nostril, each tuned to detect specific chemical signatures. When you breathe in, molecules from food, perfume, smoke, anything airborne, they bind to those neurons and trigger a cascade that becomes smell in your brain. Olfactory neurons are unusual. They're one of the few neurons in your body that regenerate throughout life. But the rate of regeneration slows after middle age. By 65, more than half of adults show measurable smell loss when tested. By 80, it's more than 3/4. Here's the part most people don't know. Your sense of smell is directly wired into the limbic system, the part of your brain that handles memory, emotion, and recognition. When smell fades, those circuits get less input. Decreased smell is one of the earliest documented signals for cognitive decline. Not a cause, a signal observed in research before other symptoms appear. If food has been less interesting for years, if perfumes don't register the way they used to, if you can't reliably tell when something is burning, that's not your imagination. That's an entire neuron population running thinner than it used to. Taste is the sense people most often blame on aging, and most often misdiagnose. Your tongue has between 2,000 and 8,000 taste buds, each containing 50 to 100 specialized receptor cells. Unlike olfactory neurons, taste receptors regenerate every 10 days throughout your life. So pure taste, the ability to detect sweet, salty, sour, bitter, umami, actually holds up reasonably well into your 70s. The decline you experience as taste is mostly smell. Your perception of flavor is roughly 80% olfactory. When you eat something, volatile molecules travel up the back of your throat into your nasal cavity. That's called retronasal olfaction. It's why food tastes flat when you have a cold. The taste buds are working, the smell circuit isn't. So when food becomes less interesting after 50, it's when seasonings need to be stronger, when meals feel less rewarding. What's actually changing isn't your tongue. It's the olfactory neurons we just talked about, doing double duty for taste and not keeping up with either. Touch is the sense people forget to count, and the one with the most surprising consequences. Your skin is covered in mechanoreceptors, specialized nerve endings that detect pressure, vibration, temperature, and motion. Different types for different signals. Meissner's corpuscles for light touch, Pacinian corpuscles for vibration, Merkel cells for fine pressure, Ruffini endings for skin stretch, free nerve endings for temperature and pain. All of them decline with age, but the most consequential decline isn't on your fingertips, it's in your feet. The mechanoreceptors in the soles of your feet feed your brain a constant stream of data about where the ground is, how flat it is, whether your weight is shifting. Combined with input from your inner ear and your eyes, that stream is what creates balance. When foot mechanoreceptors decline, and they decline measurably starting around 50, your brain has less information about where you are in space. Studies show somatosensory deficits in roughly a quarter of people in their late 60s, more than a third in their late 70s, and over half past 85. You don't feel less, you feel less precisely. And that imprecision is why falls become more common after 60, not because muscles failed, because the sensory input that tells your muscles where to go has thinned. 5 senses, 5 separate decline pathways, none of them dramatic on their own. But here's what your brain has been hiding from you. Vision compensates with brighter lights. Hearing compensates by leaning in. Smell compensates by adding salt and seasoning. Taste compensates with smell. Touch compensates with vision. Every sense leans on the others when its own data thins, which means by 60 you're not running on 5 sensory systems, you're running on one composite system, and most of the load has shifted to whichever sense is still strongest. When that one starts to go, the others have nothing left to lean on. The most useful thing you can do with this information isn't a treatment, it's awareness. Pay attention to what you've stopped noticing. That's where the data actually is.